kind of understand, I guess, your position a little better. Like, do you believe, because obviously if you look at, say, dogs, mice, we'd agree they're both mammals. So would you say that, you could get a dog as small as a mouse or even an elephant, right? That's a mammal as well. Do you believe we can get a dog as big as an elephant? Because we know there's animals as big as mice and elephant, like mice and elephants. Like, how do you feel about that? Are there genomic limits, physical limits? Go ahead.
I mean, I think if you're talking about a particular animal, there's, we see different kinds of animals, and we see that they have different expression of traits.
Check the side, Immutable.
Huh?
Check the side.
Yeah, I know. I've taken genetics, I know. But anyway, back to the question he was asking. I think there's some limits when you start talking about, like, if you're talking about, like, embryonic development and kind of the proper size for an organism to be. You do see relatively small species like chihuahuas and things like that. But
well, do you believe that you can get a dog? So obviously I understand that, because I'm not arguing that obviously, domestic dogs, wolves, coyotes, foxes, dingoes, I would say that they all descend from a single common ancestor. But like, when it comes to the change and the limits within the change that we see, like, do you believe we can get a dog as small as a mouse? Because we know they're both mammals. We know animals exist that are as small as a mouse, like a mouse. So do you believe that that would be possible given, say, enough time, enough change, enough processes? Go ahead.
Well, I mean, I think part of what defines a dog is characteristics we ascribe to it. So asking, can we get a dog as small as a mouse is kind of, in its own right, a nonsensical question, because what you're asking in essence is, can a dog have such a level of similarity as a mouse does? Well, I mean, to some extent, if you're comparing it genetically, but on a physiological level, not really.
Well, like, do you believe that dogs, mice, and say elephants are related through common ancestry? Like, if you go back far enough in time, are you gonna be able to trace back that common ancestry, whether it's within a phylogenetic chart or go ahead?
Yeah, you would. I'm not a phylogeneticist, so I would
and that's understood. Because I would say that, I can't exactly tell you where that barrier is or where that limit is. But I would say no, you're not going to get a dog, say, as small as a mouse or as big as an elephant, right? Because I would say there's limits based on that.
Sure. I mean, I think sure, I would agree to that much. But I think if you're going more in terms of like retro, if you're retro and if you kind of trace back thinking, right, there comes a point in time where dogs begin not to be what we would consider dogs. There's something else. They come from a more primitive species, and these primitive species come from even more primitive species.
Okay, so for example, like, I understand the law of monophyly, like, we never outgrow our ancestry, right? So say the origin of, eukaryotes from prokaryotes, a eukaryote will always be a eukaryote, and then, a mammal will always be a mammal. Like, we're never going to outgrow our ancestry, right? So I understand the law of monophyly, but would you say that, like, say, a population of non-dogs today came from something that was non-dog long ago and far away? And do you believe that a population of dogs today, given enough time in the future, could become something non-dog? Go ahead.
Well, to answer your first question, yes, a population of non-dogs did become a population of, eventually gave birth to successive populations of what we do consider now dogs. The evolution of Canis lupus to Canis lupus familiaris.
Now, if we, and I understand the law of monophyly, obviously, if we see, say, dogs producing a variety of dogs today based on, the genetic code, I would say that there's obviously limited information within that dog gene pool. Is it scientific, empirically, to say that dogs today, given enough time, that they came from something that was non-dog long ago and far away? Like, is that empirical science in your opinion?
Yeah, I would say it is, because I would say that, now granted, I'm not a geneticist, so I don't have access to data that, of Arctic wolves that existed what we consider to be hundreds of thousands of years ago. But from, from what I've heard from my talks with people, they would say, yeah, look,
Okay.
You can find a fossil in the ground, run PCR on it, get data from it, and compare the genome sequences, and you can see quite readily that the DNA sequences of these two things are related. And that
Okay,
particularly, there's genes that are changed and related to more social behavior within dogs, or less social behavior in dogs, which is not present in wolves.
Okay, so obviously, if we look at let's take every single dog on the earth today. Let's throw them into say Alaska. Okay, over time, obviously, I believe natural selection is a fine-tuning selection process. Natural selection is going to select that trait, say for long, thick hair, thick fur. Over time, all your dogs are mostly going to die except for, say, your huskies, right? All you're going to be left is probably with a population of huskies, right? Take those huskies, throw them into, say, the desert of Australia. Natural selection is going to select out that trait, say, for short, thin fur, skinny legs, something like a dingo. Then all you're left with is a population of dingoes. So natural selection is selecting from that pre-existing information, but all you're going to get are a variety of dogs. Go ahead.
Actually, but stop there for a moment, right? Are you familiar with the saying that the genes are plastic to the environment?
I think I understand. Can you explain it?
So, with genes, saying that genes are plastic to the environment, it refers to the fact that genes, fundamentally, what they do is they code for proteins, and these proteins are used by the body in places that they're needed. But fundamentally, what it means is that when genes are expressed by an organism, right? Like let's say it's in the Arctic Circle, or in the Sahara, or someplace like that. The function of that gene is influenced by the environment that organism is present. So, the difference between the Sahara and the Arctic Circle, right? Some organisms, due to the temperature or due to the pH or due to certain lack of resources, may express those genes at a particular rate. And the proteins that are produced by these genes may only be used in a specific way.
Okay, so are these genes pre-existing genes, and now there's, say, new traits, new proteins arising from, say, an amplification of that pre-existing information? Like, is this process that you're talking about, is this going to take a non-dog into something that's dog, given enough time, given enough processes change? Because in my opinion, and I think it's pretty evident that mutations, they're not construction, they're destruction, right? We see a significant loss of information in regards to, say, mutations. So how are you going to get?
Well, I would disagree with you on that point if you were going to argue that mutations can only cause damage to a genome, or that mutations are only deleterious to the genome.